landscape vista. If you go to the mountains in the Himalayas, it's a hill vista. So it's different kinds of views. So I work with the Indian Institute of Astrophysics in Bangalore since 1976. So I am more or less a Kannadiga in Karnataka. And but I can still speak Odia. So sometimes anybody has a doubt and unable to understand English too well, you can try to ask me Odia, but only the non-technical terms, not the technical and scientific terms. I cannot tell you Odia. Okay, so in the course of this, giving you a view of these vistas, I have also woven in some aspects of the subject, which are the tools of astronomy, which is the first tool in astronomy. Sorry? No. No, your eye. First tools were your eyes. Or other people's eyes, may not be yours. But so then we talk about the sun and the stars. And finally we talk about galaxies and our universe. It's a very broad range. So how many of you all have been to the planetarium and seen views of the sky? Only one hand there, 2, 3, 4. Don't feel shy, those who have seen. Okay, but a minority I can see. Not a large number of people have seen it. Okay, so what we'll do is, sorry? Yeah, but still a small number. I don't see majority hands going up. It's okay, fine. So we'll do a planetarium here. So this is a typical daylight view, and this is now set up for, you'll see in the bottom, for the latitude and longitude and altitude of Bhubaneswar. And so this is what you would see, but the landscape is of some other place, doesn't matter. Grass is grass everywhere, and trees. So in the ancient times, when people first tried to figure out, you cannot avoid all other science, you can avoid because they have to be specially made, some experiment or some deeper thinking. Think about other aspects of science. But about the universe, you cannot avoid because it's right there all the time. Of course, during the day there is not too much, except for the sun. What I am doing is, if you stand out on the somewhere in the open space, and you wait for many hours, you will see the sun rising and then the sun setting. So this is the same view, only I am making it a little faster. Otherwise, my lecture won't end for 12 hours. Okay? So I am just making that a little faster. So it will become night. And then it becomes day again. And then it becomes night. Now I am pointing south. But I can change my view and look east. I am showing you all this in a little detail because everybody said telescope is the first instrument. First instrument is your mind and your eyes. That is how astronomy was. A lot of astronomy was actually discovered. Aspects of astronomy were discovered. So, it become too fast. So, people long ago saw this, that things rising in the east and then setting in the west. And whenever the sun came up, something they called the sun, it was bright and it lit everything. And a lot of life and plants, both of animals and plants, a lot of life and other aspects depended on the sun. Okay, but they could not avoid seeing that things were coming up from the east and going down to the west. And these were ancient wise men, whether the rishis and munis in India or other philosophers or other wise men in other countries, all of them observe this, because from everywhere on the earth, this is the first thing you see, the sky. Okay? And it is overwhelming, in the sense that you can't help being impressed by the things in the sky, provided it's clear, of course. There should not be clouds. And those of the people in those days who were more curious and who observed over a longer period of time, mind you, you cannot observe during the night all the time, but they saw that everything was rotating around, seemed to be rotating around some point. Everything was rotating around some point. And similarly, if they went to the south, look towards the south, they saw that everything was rotating around a point, but that point was below the horizon. But then in due course of time, I mean, there was a lot of navigation, people were sailing around in ships and they went further south. The Greeks, for example, and perhaps also the ancient people from India who went to Indonesia and other places. So when they went further south, they saw that southern point around which things could also be seen when they went further south. Okay? So then they concluded, of course, that was erroneous. That's not a correct conclusion. And it has more to do with the anthropocentric view that people have. See, all human beings have an ego. I don't know about other animals. I think other animals also have ego. Human beings have an ego. They see something, they tend to see everything is around us, centered around us. That is called aham bhav, what you call it, right? So people naturally thought that the whole universe is rotating around us. And this happened not only in India, but also in Greece and Egypt and many of the other societies, ancient societies. In course of time, of course, as there was progress in scientific thinking and in mathematics and in physics, then they correlated certain observations and they realized that the heavens are not rotating around us, but the earth is rotating. Okay, therefore we see this. Sorry, did somebody say something? Sir, not audible. Okay. Well, so what I said was that it took some time. Initially people thought that the universe was rotating around us, around the earth. And it took some time and a lot of observations over many centuries before they could say conclusively. I don't know in Indian mythology whether this conclusion was reached and at what time. But certainly it was Copernicus in Europe, as late, as the 16th century, 15th, 16th century, Copernicus, Tycho Brahe, and these people, who concluded from measurements that all this happens due to the rotation of the earth itself. So what we can do is, during the day you don't see anything. So for convenience, what we will do is, we will remove the atmosphere. Supposing you are on the earth and there is no atmosphere. So this is what it will look like. The sky will not be bright and blue because there is no atmosphere. The sky looks bright and blue because the molecules in the air scatter the light. Okay. So it would be very nice for an astronomer like me to live in a world like this, but then you can't breathe, right? But this is just to show you so that you can see all the time. So what happens is, if you are out in space, above the atmosphere, you see everything. Okay? You are not hampered by the bright sky. And coming back to the ancient vistas of astronomy, I mean, primitive people, what they tried to think is they tried to make patterns of these stars. Okay? For example, let me see. We take let us see our own Indian Vedic. I think some of you might start feeling chakkar, so I'll slow this down. Okay. So, if you see our Vedic lore, there were people here who named stars. You can read some of them. Can you read from the back? Now, the universe is very big, but this screen can't be bigger than this. Well, maybe somebody in front can read out the stars. Okay? We should assign this job to one person. Maybe we'll assign it to you. You read out the stars. They are all Indian names. As and when you see the labels. Okay? So, so what the ancient people did was, what they did was, they gave names to those groups of stars. Those are in blue, the star names are in white. Okay? And they drew pictures, they connected lines among some of the stars, like here you can see. You can see there, they connected lines to different stars and made imaginary shapes. Okay? And then, of course, they drew pictures and imagined imaginary beings in the sky. You can read out. These are all Rashis. In India, they Moola Rashi. Okay. You must read loudly. Your friends should be able to hear. So this is what people did in most places. Yeah. So in this manner, they identified this. They drew pictures. You can draw any kind of a picture, draw any line. Okay. And so it was done in India. It was done in many other places also. For example, I think the Koreans had a lot of names. They gave all kinds of names. There was one named Toilet. They imagined some shape it was a toilet, so they called it a toilet. So all kinds of names. Chief of Farming. And civil engineer? Okay. So these are not as old as the Indian ancient astronomers. They gave all kinds of names. Okay. So in our Indian system, okay, coming back, in our Indian system, if you remember what I showed you, only certain parts of the sky had names, unlike this Korean one, for example. Okay, and those are all along one path, which defines the path the sun follows in the sky. In other words, they are in the apparent path of the sun in the sky. You see, all the constellations there only they name. So the rest of the sky they did not name anything. So you have great opportunities. Many of you can join stars in the other place and fill in pictures and give them names. It might be a good thing to do. Because in India we do not, the ancient rishis in India did not cover the entire sky. They only covered the ecliptic, which is the apparent path of the sun on the sky, only in those areas. Okay, sun and moon, some range of positions there around that. And then of course, there were things like this. Can you see that there's a patch? Like a cloudy kind of patch there. I'll show you this mouse here. Okay, in that area. They saw areas, this was seen by everyone, the areas which appeared to be patchy and cloudy. So like that there are many areas in the sky which they didn't understand. So much later it was found that those are groups of stars so close together that you cannot see the individual stars and the whole thing appeared like a milky patch. So later on we called it the Milky Way. What is the Odia name for Milky Way? Akashaganga. Okay. So these were all names given in the earlier days because people actually saw it. You have proof because you know the name. Okay. So if you see, as I told you, in our Indian system, they only had a patch, so that you see it if you look east like this. Okay, so all again you see part of the Akashaganga, which is the central crowded regions of the galaxy, of our galaxy. I'll tell you shortly what galaxy is. So only in one band all these constellations arose. So maybe KIIT can organize a competition for all the children to make pictures in the remaining parts and give them names. So these were the views which people had, but since now we are in the 21st century and we have computers and software and we know all the positions of the stars which all our ancestors have measured, so we are able to plot all this. So there was a lot of work which went in. So astronomy in the earlier times was mostly looking at positions of stars and movements and doing a relative measurement, saying that to the eye this star appears 2 times brighter than that star, or another star appears 5 times fainter than the first star. So this is the way things were. It's not very modern and doesn't sound deeply scientific, but this was all that was possible a couple of thousand years ago. Okay? But it is remarkable that people watched. They could not remove the atmosphere, so day after day they had to watch and note the position of everything, maybe on Talapatra in the old days in India, that where the star was, they will be seeing some mark on the horizon and say it was so many degrees away. And in some other season they will measure it is so many degrees away. Of course, later on, when Jantar Mantar and constructed, masonry constructed position measuring devices were there, they could measure more accurately. But these were still scientific measurements, or attempts at scientific measurements, which are very involved. It took a lot of effort. Also a long time. Okay. So this is, and more or less, this is the manner in which ancient astronomy, from the Greeks or the Egyptians or the Indians or the Chinese, it was done. It is only much later so I told you about the view of the sky and the human imagination. Much later, when people invented instruments, and mind you, this is a development not necessarily for astronomy. There were developments going on in all sciences. So people were looking, glass was invented in some way. First it was found naturally, and then it was made artificially. Quite early, 15th, 16th century, 16th, 17th. And then people saw there was a magnifying property of glass. Things look big. You can find an old bottle. Those days it was not available so easily. But you can find an old bottle, and the bottom of the bottle, if you see, it's got a thicker part in the middle and thinner part in the end. You just look through that, you see things are magnified. So this is what people realized even earlier. And then they realized that that's the science of optics. In physics, there's a branch called optics. The science of optics was born. People figured out all the laws governing magnification and focusing of any image or any object onto a plane. And it is during that period that the first telescopes were kind of made. Who is this man? Oh, everybody knows Galileo. Nobody knows me. Okay, very good. Galileo Galilei, very famous person. He invented the telescope. Okay, this is a picture of usually only rich people were involved in all. So these are all the nobles in Italy, in Milan, whom Galileo invited, and some of the common people later on got a chance to view his telescope. So this is obviously in the day, trying to view the sun. Somebody must have got also badly hurt trying to see the sun directly. That's the model of one of his early telescopes which he made. It's in a museum in Italy. And these are pictures which Galileo drew. He looked at the brighter kind of objects. Those turned out to be planets, Jupiter, Saturn. When he looked at some of the stars, he could not. It just looked brighter, he could not see it. But some of the planets in our system, he could see. They look like this. Just like the moon, you can see different phases. He could see similar phases for the planets, Mars, Jupiter, Saturn, and he made sketches like this. Okay. So these are all these are originally available, and they are there in the in a book he wrote called Day4, first book he wrote on astronomy. And so telescopes. So we look a little bit about after 1600 we come to 1700s, 1800s. That's the time more modern telescopes got made. And there are different kinds. This is the kind of telescope which Galileo had. It has a lens. It looked at some object and it made an image. Later on, after people tried to make larger and larger telescopes, Galileo's telescopes was very small, around 60 millimeters or so diameter. When they tried to make it larger, they realized that the images were getting distorted. That is because a lens, you can only hold in the edge, you cannot hold it below, because it blocks the light. And as you get larger and larger lenses, the glass itself becomes so heavy that it starts distorting. You can only support it at the edge, and the edge is sharp. Sometimes it will break. So then someone thought of the idea that we could have reflectors. Instead of the light passing through, they reflect. Much like in the headlight of a car, you have a paraboloidal reflector. Light comes in and gets focused. And there are various forms of that. One is reflector is of this kind. Notice that this particular image shows focus coming from different areas to different points. Those are called the aberrations in optics. That is spherical aberration, chromatic aberration. Okay, this is chromatic aberration. So ideally, we will want all the light from all parts of the reflector to come here, and all wavelengths also. They have to be corrected. So later technologies were put in to correct all that. And these are different kinds of telescopes which are used quite a lot even today. Now I should tell you, so this is the simplest telescope here. This one. The single mirror brings to a focus. But there is a problem with it. If you want to take a picture at that focus, you will have to put your cell phone camera right at that focus. If you put it there, then you are blocking the light which is coming in. So any instrument you put there, you are blocking the light. So people came out with other ideas. So they put a mirror like here, and they folded the light. But that mirror again in turn blocks something. Okay. Then people said putting just the eye there is not sufficient. Later on there were quantitative methods found to measure the light, to do more measurements of its brightness, certainly, and in various filter bands that I'll show you later. Okay, to understand quantitatively instead of just qualitatively. So they wanted to build instruments. They wanted to build spectrographs so that that light at the focus can be on going to a spectrograph and give a spectrum. The advantages of a spectrum. If any of you don't know, have you heard of spectrum and you know spectrograph? Most of you know. Okay. So you get spectrum lines and then you can study what the source, what chemical elements are present in the source, that is the star or nebula. Okay. So when you start building instruments and they get bigger and bigger, you can't put them here. So they found this configuration, where there's another mirror, brings it down. So at the bottom of the telescope, below the mirror, you can attach instruments. So these are various kinds of telescopes. So, as I told you earlier, mentioned earlier, not just the big difference between the telescope and the older method of just looking with the eye, but in the 1700s, that is the 18th century and 19th century, there was a lot of progress in physics, particularly end of the 19th century and early part of the 20th century, which allowed us to transition from what was purely astronomy, which is positional astronomy, which all the ancients used, to astrophysics. Astrophysics means you are actually trying to apply physics to the celestial objects and understand it from a point of view of principles of physics. Okay. It's all right to say this star looks bright, 2 times brighter than the other star, but why? What is exactly a star? The ancients thought very long back, even in Europe, I tell you, not so long back, before the 16th century, They thought that God or somebody had fixed lights in the sky. It's like a ceiling, a round ceiling. And some lights had been fixed by God. And this whole thing was rotating around us. So that was primitive thinking. So then the vistas have changed with physics a lot. Now we understand each and every, more or less each and every object. I mean, I can say, look at 30, 40 people like this and study their behavior, and I say, I more or less understand the behavior of people. Doesn't mean there isn't some odd person somewhere else whom I fully understand, but by and large, statistically, we can say we have understood that. So, progress in physics and instrumentation. By instrumentation, I mean there is a lot of engineering involved, electronics engineering, mechanical engineering, optical engineering. So many things are involved. Some of you don't realize that these phones and cameras which we are using, they are very complex instruments. Okay. Some of them have GPS, they connect, they get accurate time from satellites. They show you all kinds of information, they can show you maps. In fact, whatever I am showing you there, the full sky chart can be seen on the cell phone today. Okay? There's a lot of technology going in. Okay? And so then we come to some technicalities which are now commonly used in astronomy. It's called the first important thing is the diffraction limit. Why do you have a mirror? Why are people making bigger and bigger mirrors or lenses, if you like? Now, an optical telescope is defined by its primary mirror. The first mirror where the light from the sky strikes is called the primary mirror. Or if it's the lens telescope, the entrance lens where the light strikes, that is called the primary lens, objective in the case of lens. So telescope is often referred to, if I say 2-meter telescope, it means the primary mirror is 2 meters. If I say a 48-inch refractor telescope, the lens type, that is the largest refractor lens type telescope ever made, 48 inches, 4 feet. So then it is the 48-inch lens, if I say a 48-inch refractor. So it is always referred to as 2-meter telescope or 1-meter telescope or 10-meter telescope or 8-meter telescope. Now, why do people want to make it larger and larger? See, most of the objects in the sky are for all practical purposes at infinity, very far away. So even if you have a point-like object like a star, it is point-like because it is very far away. It is emitting radiation in all directions. But by the time it comes from so far away to you, all those rays which are coming out, they effectively in that small area appear to be parallel. Further away it is, the more you can say it is a perfectly parallel light of rays. So it is like rain. What is like rain? All these lights coming from a star and falling on the ground. It's like rain because it is all parallel. A rain on a very still day with no wind, all falls parallel. So why I am giving this analogy for the rain is, you put a little a dekchi or something there, and you put so much of diameter, you will collect a certain volume of water. You put a bigger dekchi, a bigger diameter, you will collect a larger volume of water. The height of the water will be the same in both, but the volume is more because of the diameter. So in the same way, telescopes are like light bucket, or light dekchi, if you want to call it. The larger they are, the more of these photons from the star they collect. So you can see fainter objects brighter. The second property is this, diffraction. The larger the diameter, the smaller the angle between two objects. If I take two objects in the sky like this, and supposing your eye is here, and there is one star there, another star there, the lines joining those stars to your eye, there is an angle. Now, if that angle is smaller than this diffraction limit, then you cannot make out there are two separate things. They will merge into one. So you cannot resolve. You cannot resolve those stars. So if you want to figure out in some places like the Akash Ganga, many cloudy patches, you want to see carefully, then you need larger and larger diameter telescopes to separate the close by stars you are seeing. So this is very important. This is why people, yes? Well, this actually comes from a theory in optics. It is called diffraction through a circular aperture. So I will not go into it, but it is that theory which gives you this number. Okay. So I cannot go into the details of the. I don't know. Have you studied diffraction? No, may not have.